When you look at a spreadsheet filled with decades of temperature measurements, it may be difficult to immediately spot patterns or trends. But when you see the same data transformed into shapes, lines, shades of colour, you're witnessing something that can be understood in seconds. Today we are discussing the visual translation of climate science, what is called data visualization. Hello, I'm Claire Nazir and welcome to Climate Conversations. Representing climate information visually has become integral to how scientists communicate vast patterns of trends to audiences beyond academia. Whether you work in energy planning, public health, agriculture, or simply want to understand how our climate is evolving, these graphics serve as bridges between complex data and clear understanding. There's extraordinary skill required to produce this information in ways that are simultaneously digestible, factually correct and actionable. The most famous example is the climate stripes, those simple bands of colour representing temperature trends through decades, scaled from a single city to an entire country to the whole world. They've opened a door showing that climate evidence can be both rigorous and accessible.
I remember putting the slide up at Hay and just being able to say to someone, this represents the temperature change in the town of Hay, going from blues to reds, cold to warm. It's a very natural colour scale to use for temperature. And you can instantly understand what's going on with one single glance at the image. It's very stark, it's very visual.
This is Professor Ed Hawkins from the University of Reading, the scientist behind the climate stripes, and you'll be hearing more from him through the show. Also, Alex Burkill sits down with someone who has been transforming data into imagery for many years, senior software scientist developer at the Met Office, Kaye. They'll explore how visual climate communication works. We'll look at several of Neil's creations, some you may have seen on social media and many that have been used to support the communication of climate. Over to Alex.
Neil, thank you so much for joining me today. I was really excited to talk to you because you've created all these stunning visualizations which help show pretty complex climate information in such an easy to understand and interpret way. And I'm just desperate to find out how you came about it, how you came up with the ideas. So let's dive in and look at some of the ones that you've created. So first up, so what is this animation showing us?
So this shows average global temperatures from Met Office data, and the years are coloured by how warm the temperature is compared to pre-industrial levels. And you can see as we come into the 80s and 90s, it starts going red and orange, then red, and then dark red as the temperatures increase. And this is one of the first visualizations that appeared very successfully on the Met Office's Twitter feed. And I think it demonstrated that there was an appetite for climate content as well as weather content, which was previously the only thing that really appeared. So this was about, the original version was made about 7 or 8 years ago. And as I say, it proved an interest to the public.
And what made you realise that this could be a nice way to show the warming that we've seen over the last, 150 years or so?
Well, it's quite a simple message because it's essentially just showing one thing, how the temperature is increasing. And I thought maybe I kind of thought about it, I think when I might have been cycling to work, and I suddenly thought, oh, what about if we have this animation of these really big numbers, and then it kind of catches your attention.
And why do you think people picked up on it and understood it so clearly? What do you think made people take notice?
Well, I think the combination of the very clear years and the colours, it uses blues and yellows and oranges and reds to indicate colder and warmer temperatures quite effectively, I think. And then the other side is showing the thermometers showing how the temperature's increasing as well.
And it's interesting, isn't it? Because near the beginning of the sequence, the temperature rise is not particularly quick.
No,
It's quite stagnant. And then as we go on, it gets quicker and quicker.
For the last 20 years, the temperatures have certainly accelerated. The increase in temperatures has accelerated.
Which isn't a huge surprise based on other data and the information, but it just shows it in quite a instantly alarming way, really.
Yeah.
Next up, we have this map of the world, but what is it showing?
So what this map is showing is it's a map that might have appeared in the classroom, and it's the Mercator projection, which is actually a projection that was originally used for navigation. But what it's showing is that there's a massive distortion of countries that are closer to the poles. So this is a visualization that is going to show how much the distortion is of these countries at the poles. So for example, looking at Greenland, it looks a similar size to Africa, when in fact it's 15 times smaller. So this is taking obviously the globe, which is spherical, and putting on a flat map, and so then things get distorted. That's right.
Whereas, and so you've taken that and then animated it. So
what we're going to see when I set this off is it's going to animate the countries to the size that they actually are in reality compared to what it appears on the map. And this was something that was probably the first thing that went viral for me when I put it on Data is Beautiful on Reddit, and it got quite a large interest.
I suppose so. This isn't climate related.
No, this isn't climate related, but it's an example of how creating a visualization with a single message is quite powerful. Like in the previous one with the numbers and the climate, you've just got one message that the world is getting warmer, whereas this is just a single message to show how the countries are distorted in size in reality, and then the idea is to animate it so that you can see how much distorted they are, and so you can see Greenland shrunk massively. And when you look at Africa pretty much stays the same size because it's near the equator. It doesn't get distorted in this projection. And I also designed it with the idea of if you imagine a balloon effect, when you have a balloon that's not blown up, it's an intense dark color, and then as it expands out, it gets paler and paler.
I get you. Hence the colors.
Yeah,
so that you can see how much they're changing.
And you can see the size distortion is coloured up here. So these dark blues are basically hardly distorted at all, whereas the pale blues are 100% bigger. Like within the UK, we're about 100% bigger than we should be, and then by the time you get to Greenland, it's almost, as I said, about 1,000.
And so the balloon, if you will, has been stretched a lot. Hence why the colours faded.
Yeah, that's right.
It is a really nice way of showing something that many people know this in as much as know that the difference. But I think Greenland, for example, it's remarkable how much smaller it is in reality compared to what we're used to seeing on some of the maps. North America as well, for example. That really stands out.
And also in the Cold War, it was a very political thing because Russia appears, Russia is massive, but it appears even more massive on this map.
It's really striking. So impressive. It's a really interesting way to see the difference between what we often see in books and on maps, etc., and what we'd see on a globe instead. Neil is an expert when it comes to data visualization, specifically when it comes to climate communication. And when we're looking at climate data visualizations, one that really stands out are the warming stripes. I caught up with Professor Ed Hawkins, the man behind these iconic stripes, at the University of Reading to find out the story behind them. Ed, thanks so much for joining me. First of all, let's talk about the jacket. What's it showing? It's showing the warming climate stripes, right?
It's quite a jacket, isn't it? Yes. So this is representing changes in global temperature in jacket form. It was made limited edition by a company, and I was lucky enough to be sent one, so I could wear and show off the warming stripes in person.
I need to get one of these for one of my broadcasts coming up. But let's talk about the climate stripes. Walk me through the process. When did you realize that it was going to work, that it was going to really represent things that traditional graphs couldn't.
Yeah. So I guess the trigger was being invited to speak at the Hay Festival, which is a famous literary and book festival. And I was partnered with an amazing poet called Nicola Davies to put on an event about climate as part of the Hay Festival. And Nicola wrote some beautiful poems about climate science and climate changing. And I was there at the event to support her with some science. And so I wanted a way of talking about climate change in a way which would reach an audience of book and art lovers. And so I wanted a very simple visual way of representing the changes that we see. And that was the key spur for developing the graphic. I also remembered a conversation with a colleague the year before who had knitted a blanket with some stripes on
Oh, okay.
to represent changes in temperature. And we had a long chat about colour scales and colour things to use. And so these all things came together to build this graphic. And I used the graphic for the town of Hay itself at the event. And I could see people's eyes open at the time going, oh, I get it now, because they could see the changes happening even at the scale of a small village like Hay. You can see the trends. We are experiencing a climate change wherever we happen to live.
What was that first item that had been knitted? What was it?
It was a blanket for a baby.
Oh.
Yeah. So a colleague had knitted a blanket for a colleague who's having a baby. And so that person still owns the blanket now. Yeah. And yeah.
And I suppose for a baby, that's really important, because when we talk about climate change, we're talking about not necessarily our generation, but future generations, our kids' kids, and going forward.
The decisions we make now are going to ripple throughout that baby's life. Yes.
Now, when it came to the climate stripes, you streamlined it. You ripped things out. You took away the axes. You took away the keys. You made it simple. How did that help?
I think because it tells a story. You know, I remember putting the slide up at Hay and just being able to say to someone, this represents the temperature change in the town of Hay, going from blues to reds, cold to warm. It's a very natural colour scale to use for temperature. And you can instantly understand what's going on with one single glance at the image. It's very stark, it's very visual. And many people just work visually without having to worry about numbers and maths and axes. It probably reminds, if they see axes in a typical graph, it reminds them about school days when they may not have enjoyed maths or science, but this way they can grasp the concepts just by a single glance.
I think that's true. It's so striking, and it's hard to argue.
It hits you in the face.
Exactly.
Yeah.
But on that note, the process of removing the axis, that does trigger some people to claim it's alarmist. How do you deal with that?
It certainly breaks the rules, right? And of data visualization, and people have come up to me and said, you know, this doesn't represent the data, but it really does. It's the same data that we normally talk about. It's just presented in a different way to reach a particular audience who would not necessarily otherwise realize what was going on. And so it's a very simple way of talking about climate change. It's not the only way we should talk about climate change by any means. It's one example of a whole range of techniques that we might use for different audiences. For an expert audience of policymakers, we would not use it. We would use a very different way, which had all of the uncertainties and represented all of the details that we need to represent. But for a large number of people, just having the basic facts is something they're not aware of often. And so being able to represent that as simple, as clearly as possible is really important.
Neil, that philosophy that Ed talked about, stripping things away and making things simpler to help them stand out more, has that helped inspire you? Has that influenced some of your projects?
Yeah, I think so. The climate stripes are very simple, and they use clear colours, blue for cold and red for hot. And so they're very obvious to understand, and you know, they appear everywhere on t-shirts and all over the place. This is an example of a very pared down visualization without axes and anything like that. And it was inspired by the painting by Hokusai of the Great Wave in terms of the colours that have been used.
The palette that you've used. Yeah. It looks familiar, and that works, doesn't it? The familiarization helps reach people in a different way.
But what it is actually doing is showing real data. So I updated this for the podcast up to the end of 2025, and it's showing global mean sea level, and the lines are going from January to December along here, and then they're in 4-year intervals from 1993 at the bottom to 2025 at the top. So you can actually, so they actually mean something. So this is essentially the sea level rise through time.
So you can see the fluctuations through the year.
Yes.
But the one thing that's standing out is that sea level is getting higher and higher.
That's correct. Yeah.
And you can really see that change. And whilst it's artistic,
Yes.
and it's nice. And so you've talked about your inspiration behind it. But when did you realise, hold on, I've seen this artwork, I could use something similar to this to demonstrate this, let's be honest, concerning changes that we're seeing to sea level rises?
Well, there was a competition that was put on by, I think it was ECMWF, and it was called a Little Pictures competition. So I entered this, and it got like highly commended from the judges. So it obviously was quite successful as a kind of, it's almost like a piece of visualization, but then an art at the same time.
And you have plenty more examples to show us. Let's look at a different information set. So this chart we have here shows us information about global fossil fuel emissions. It looks a bit more like a traditional graph that you might see in other papers compared to some of your other visualizations. Tell me about it.
Yeah, that's correct. It's probably more traditional, other than the fact that maybe instead of lines, I've kind of separated out the percentages with kind of a gap, like a pale line. But what is different about this is instead of changing the visualization to one similar to the previous one, the previous one we created almost like an artwork of a visualization, whereas this is more about reframing the data. So there might be a misconception that the 19th century, the Industrial Revolution, that's when there was a lot of pollution and carbon emissions. But as it turns out, if you're 50, 75% of all emissions have occurred in your lifetime, as in since 1975. And if you're 30, it's more than 50%. So more than half of carbon emissions have occurred if you're 30.
And so even though, you know, in the grand scheme of things, a 30-year-old hasn't been around for that long,
yeah,
half or more than half of the fossil fuel emissions have occurred in their lifetime. So it helps illustrate that the emission rate is rapidly increasing.
Yeah. And in fact, in 1 year, it's almost like the equivalent of the whole 1800s. Like today, this year is almost like the complete emissions for the 1800s.
Oh wow! For that,
So
the whole century.
Yes, for the whole century.
And that really goes to show just how much we're doing and abusing the planet, I guess.
Yeah. So I mean, if you're 85, for example, then 90% of emissions since 1750 have occurred in your lifetime.
That is shocking, isn't it, when you think about how much is going on? And also when you take into account the fact that, you know, there was a time when people weren't aware of the impacts of fossil fuel emissions, but we are now.
Yeah.
And so you'd like to think that things would be shifting, but they don't seem to be.
Not at the moment, although I think there was an article saying China may have peaked this year.
Yeah.
And maybe possibly slightly on the way down, but it's the emissions are so much higher than they were in the past that it's still a long way to go.
Yeah, I see. So we need to, it's good that we're starting to plateau, but we need to rapidly go down as well.
That's right.
Let's keep going because you have plenty more to show us. Now, there's a lot of data on this infographic, this chart here. What's it telling us? It's looking back at 2025, is that right?
Yeah, this summarises 2025 over the UK for temperature, rainfall and sunshine. And the graph that you see at the top with the black line is showing the average temperature between 1991 and 2020 for each day of the year. And then the blue is when it's colder than average, and then the reds, all the red peaks are when it's warmer than average. And last year was the warmest UK average temperature that we've had on record. It was 10.09 degrees, and you can see that there's been consistent warmth throughout the year, and it was quite a dry year, and incredibly sunny. We had the warmest, the sunniest spring on record, and also the warmest spring on record. There's a few design things that make this data visualization easier to understand. For the temperature, we clearly use blue and red because that's seen to be cold to warm.
Like with the warming stripes.
That's
yeah,
right. And then for rainfall, I'm using sort of browns to bluey greens to indicate dry and wet. And then for sunshine, we've got greys to kind of bright yellowy oranges. And also these colours are colourblind proof. So people, about 4% of people are colourblind and have problems differentiating between reds and greens and purples and blues. So these colours would work for them as well.
Yeah, it's important for accessibility for sure. I remember looking at this chart earlier on, and it is, I mean, 2025 did stand out just for how consistently warmer than average it was. Yes, there were a few periods where it was cold, but never massively so. Whereas, most days were so warm, and it's no wonder that at the end of the year it was really warm. Now, we're obviously talking in February now on the back of what's been a very wet spell across many parts of the UK, and so it's interesting looking back just at how dry the majority of 2025
last year was. But the beginning of this year has been super wet, and that will be reflected in
this year.
Because I generate these charts at the end of each month, so it goes back for the previous, shows the previous year as a kind of summary for people to.
And you can really see that turning point, wasn't it? It was around October time when we went from so much dry weather to something about normal. Autumn often brings changeable spells, so some drier, some wetter spells, and then end of autumn, beginning of winter, that's when the fairly relentless wet weather just continued. But you can see that so clearly in these charts, and you can see it also with the sunshine one, just the drop off in sunshine. I mean, that's climatologically average for us to see less sunshine as the days get shorter. That's of course what you'd expect, but you can really see how much sunnier than average it was for particularly spring, and then the fact that it's turned gloomier through the latter part of the year. So a really nice visualization to take in a lot of information here about the year and see how different it was to average.
Yeah, the other thing is it uses what's called small multiples, which is lots of little maps. So as well as giving you the average for the UK, you can sort of see in certain situations like January, you can see that the southern part of the UK was wet, but then Scotland was dry. So, and then in this map, for example, for June, you can see that the eastern part of the UK was dry, but the western part of the UK was wet.
Yeah, so the story wasn't the same across the whole of the country.
No.
Yeah, nice way to illustrate that, to see that and also the peak of the heat in the summer across eastern parts in particular. So there are many different parts of the story when it comes to climate change that can be visualized in interesting and easily informative ways. But when I caught up with Ed Hawkins, I asked him if there was anything keeping him up at night, anything that he was working on new, because yes, the warming stripes worked and stood out really nicely, but other factors a little bit trickier to understand and to interpret in such a clear way. Temperature kind of lent itself quite nicely to the way that you're illustrating it. Are there any other values, rainfall amount, sea level rise, anything else that keeps you up? Maybe think about how you could represent it, illustrate it in a similar way.
So we need to be able to tell stories about the data and what it means for people. And yes, you're right, this represents temperature very nicely, but it's not so good for representing changes in rainfall or maybe things that matter to people as well. So we definitely need to tell better stories about the changes we're already experiencing. Here in the UK, our rainfall is going up in the wintertime. We've had a record number of wet days just recently. The intensity of rainfall we're experiencing is going up. And that really matters. People feel that. They feel that every time there's heavy rainfall, that their rivers go higher and raises the risk of flooding. And so we need to tell those stories and communicate to people they're already feeling the effects today, now, and those consequences will continue to get worse as the planet continues to warm.
And how can you do that in a equally as striking visualized way?
Maybe this approach doesn't work for all of these concepts, and that's fine. We need to find other ways, but we need to tell stories rather than just the data. The data only gets you so far. It warns people about the risks, but it doesn't necessarily get to the heart of what they need to do, how they're going to experience those risks. And so we do need to find other ways of enabling people to realize that, yes, we're already feeling the effects, we're already feeling the consequences, and they'll continue to get worse. And so we need to find other ways of doing that.
How do you think your work that you're doing fits in with the work that the IPCC is doing in general and what they're achieving?
Yeah, I mean, the IPCC does an amazing job at summarising the state of the science every few years, presenting that to the policymakers so they have a very clear picture of what's going on in the science and where we're heading in the future. And the stripes have been used by the IPCC in one of their key graphics to highlight the changes and talk about the future as well, to highlight the future in different coloured stripes as well, to present that information as a warning, the warning stripes about the choices that we can choose now and the different pathways we might end up in. And so they have been used in that way, and also used in a way to represent the future in terms of generational experiences. Someone born today will have a very rapid change in their future. Someone born in the past has already experienced that change. And trying to talk about those cross-generational issues is really important, in a way that climate stripes can reach across generations by talking about the past and then also the future.
Now, specifically looking at the UK and Ireland, what stories yet to be told in such a striking visualized way? What other aspects of our changing climate do you really want to tell?
So I think often when we talk about global temperature change, right, that doesn't really mean much to anyone. We don't experience global temperature change. We experience the climate change wherever we happen to live. And also 1 or 2 degrees may not sound like very much to someone, right? On a day like today, 1 or 2 degrees, you wouldn't necessarily experience that. So we need to talk about the consequences of what 1 degree, 2 degrees global temperature rise means. And that means in the UK and Ireland, for example, we see much hotter heat waves. When we get a heat wave now, it's not just 1 or 2 degrees hotter, it's 3 or 4 or 5 degrees hotter than it would have been, because the hot days are warming faster than normal days. And so we are experiencing the effects far more keenly when we get extreme weather. And it's the same for rainfall. When we get heavy rainfall, it's going up by a lot. We're getting much more rain falling from the sky, which means our flood defences potentially get overwhelmed. And so we need to learn to deal with these very large changes in the climate when it matters to us, which is when we get the extreme weather. When the weather conspires to give us those really bad weather days, the consequences are much worse than you might expect.
So Ed's identified that temperature was a breakthrough, but other metrics when it comes to climate information are a little bit trickier to display in such an informative and standout way. Rainfall, for example, and also severe weather events. But these are the type of things that Neil is exactly working on to help illustrate. Now, Neil, we have a chart here, and this one's looking at the relationship in the past through climate between rainfall and temperature. Can you explain a bit more about it?
Yeah, so on a day-to-day basis, we describe weather where some days will be very hot, or they'll be very cold, or there'll be a massive amount of rain. But to get an idea of the climate we're living in, we have to do very long-term averages. And normally for a climate, we do a 30-year average. And so what this visualization is going to show when I start it is that in the 20th century, this pale blue box has all the range of climates that occurred in the 20th century. So the average rainfall over the UK was between about 1,060 mil to about 1,100 mil, and the temperatures were 8.2 to 8.5.
Quite a small box.
Quite a small box.
I'm looking at your axes and seeing that there's room.
So if we run this through, what we're seeing is 30-year average temperatures and 30-year average rainfalls. So if I pause it here, for example, this is the point when it was the 53 to 1982 average rainfall and temperature. and then do it a bit longer, 64 to 93, and then we've paused it here, and we can see this is the 1971 to 2000 average for rainfall and temperature. We're starting to leave this box, but if we run it through to the end, we can see that by the time we get to the 1996 to 2025 average, we're approximately almost a degree Celsius warmer than we were
through the whole of the 20th century.
Through the whole of the 20th century. So we're already, the climatology is already 1 degree warmer, and we're also about approaching 100 mil more rain in a year.
So for a century, the 30-year average kept us within this relatively small box.
Yes.
And then once we got into the 21st century, with our warming climate, we had our temperature rising, yes, but with that as well, the rainfall amounts that we were seeing also rose. As you would expect, a warmer atmosphere holds more moisture, and that's what we've been talking about a lot of. But it's pretty remarkable that you can see the fact that we were kind of contained within this area. That's
right.
That was normal. That was usual. But then since we've got into the 21st century, that's not normal anymore, and alarmingly it keeps going up, both in terms of the temperature and the rainfall.
Projections are it will keep moving in that general direction.
Now, how difficult was it to create this chart and to come up with this box and illustrate
it's an unusual chart because it breaks the rules of what you would normally do with a scatter plot, because you don't tend to join the dots on a scatter plot. But the reason it works is because it's animated, so you can it's the key feature of this is the point where we get to 71 to 2000 when it's on the edge of the box, and then this thing here. And interestingly, I put it on social media yesterday because I'd recreated it for this podcast, and somebody said it was good foreshadowing because they were like, why is this box in the corner and why is this massive white space here? It gives you an idea of what's going on.
So really striking way of showing how things have changed since the turn of the century, with more rain and higher temperatures. But we can go back really far with our data, can't we? We have the Central England temperature. So the monthly Central England temperature goes back as far as the 17th century, but this is the daily Central England temperature, which only goes back as 1772. And I'm looking at this and I'm seeing the blues and the reds and the comparison, and I'm seeing that the red area is getting bigger as we get into the nearer times.
Each of these tiny pixels is one single day for the last 250 years. So if you look at the columns, each of these columns is like a single day, and then as we go along here, it's going from 1772 to 2025. And what I've done is drawn a line in which gives you a 30-year average of the day the temperature both rises above 10 degrees C and then drops below 10 degrees C as a kind of say a monthly average. So you can see that in the past sort of 45 years, there's been a drop from the average day that the temperature rises above 10 to be beginning of May to more like the middle of April.
So it's getting earlier.
Yeah, and it's similar. It's middle of October to towards the end of October when it will drop below.
And you can also see, because with the colours, again, the blues and the reds for temperature makes perfect sense. But you can see the darker blues that we have during the winter months in the end of the 18th century. We're losing the darker blues.
Yeah, I mean, so for example...
Even some yellows.
If we look up here, that's December 2010. And then we're going to have the 60s, 63 was a very cold period. And then some of these mid-80s periods. But since then, as you say, the temperatures are not as... They don't get as cold as they were in the past.
And the reds are getting more intense as well. I assume if we'd done this 10, 20 years ago, you wouldn't need your scale to go up as high as 28.5.
No, that was when we had the first 40-degree day in the UK.
Yeah.
And that's the mean temperature for the day. So it's very unusual for a mean temperature in a day to be above 25 in this country. In fact, it's only happened on a handful of occasions.
And they've all been in recent times.
Yeah, and all yes, in recent times. I think there may have been a few freak days in the past, but that's, as we say, it's weather, so there is going to be inherent variability. But the chances of these high temperatures are massively increasing. So the high temperatures are massively increasing, and also as I say, these are the time when the 10 degrees is reached is the period is increasing in length, and that obviously has impacts on things like growing seasons and the phenology when the leaves come out.
Of course,
and bud bursts.
Yeah, and just growing seasons and wildlife is affected by it as well.
That's right.
Now, before we move on to another thing on that aspect, it's just remarkable how much data is actually shown in this chart. When you think, what did you say, it was about 250 years worth of daily temperature. That's a lot of information to get across, and it shows the trends. You can see the colours changing. You can see the date with your 10 degrees, both the first time above and last day above. You can see the trends in those, and so it really just takes a little bit of time to get your head round. But once you actually start to understand it, it's quite a nice way of illustrating the changes that we've seen in this data set, which goes back such a long time.
Yeah.
And it's hard to argue with as well. Speaking of phenology, one more chart that you wanted to show us today. And we've left the UK now. This is now looking at the date of the peak cherry blossom season in Kyoto in Japan. Obviously, Japan well known for its cherry blossom during the spring months. But there's a drop-off in as much as it's getting earlier and earlier in the year. Actually, but let me just get my head around this. If we look back in the end of the 18th century all the way through the 19th century, it looks fairly static.
Yeah, and in fact, this data set goes back. It's the biggest, the longest phenology data set in the world. It actually goes back to the 9th century. But so that because I'd shown you that central England temperature from the 1770s, I've cropped it off. But I mean, if you were to look at it, it would be going back on a similar straight line for the previous 800 years.
Oh, I see. But in recent times, since, well, about 100 years ago or so, there's been a change.
Yeah, so it's showing that certainly in the last 50 years, these are 20-year average, these little blossoms that I've created, the 20-year average, and the little pink dots are the actual annual dates. So you can see why these are essentially, it's the day of the year. So that's day 100. These are all day 100.
Which shows quite nicely. There's still variation.
Yeah, so there's still a lot of variation. But if you look at some of these dates here,
oh wow, that's super
previous period, you're going down as early as March 25th. And if you look previously, that it was never in March. If you look in, I mean, this super early one here looks to be about like April the 2nd or something along those lines. But these are even earlier. So you can see that this downward trend matches the date of the 10 degrees being reached in the UK, as in the spring is coming earlier, so the blossoms essentially peaking at earlier days, and that's common for all kind of phenological indicators like bud burst, and that's an interesting thing because the timing of these events then impact on, say, the insects that might feed on these, and if they come out potentially a lot earlier, so, and they have potential impacts as well.
And it's interesting because we know climate change is a global thing, but we often look at it from a UK point of view. But looking at how it's impacting such something so memorable, so outstanding as the cherry blossom season in Japan, it's just fascinating to see that there are such big changes in something that is, like you say, so important for a number of reasons?
Because these early dates are unprecedented, in the last 1,000 years, as this cherry data set shows, we can't be sure of what the impacts will be on both the vegetation and the animals.
So I guess it's something that you all and many climate scientists, both here and in Japan, will be keeping an eye out for. Thank you so much for talking to me, Neil, today and going through all these fascinating charts. Before you go, are there any aspects that you're desperate to try and visualize in such an informative way? Anything that's causing you some headaches that you'd love to show but are struggling to?
I'm quite interested on visualizing some of the positive impacts that things, for example, the increase in electric cars or the increase in green energy, solar power, wind power, so that it's not always negative visualizations that I'm producing.
Yeah,
so
it's a tricky thing when it comes to climate conversations, climate communications, because it is often seen as a bit doom and gloom. But it is nice to try and find positives in the story, to see that people are making changes, that there are developments that are helping the situation. Are there any parts of the changing climate that you'd like to look at as well?
Well, I haven't shown you any visualizations that include projections, but there's I have done some work looking at uncertainty of the projections, because different areas around the world have different levels of uncertainty. And different times of the year we're less certain of what's going to happen. For example, temperature we've got far higher confidence in than we do things like the effect on rainfall, for example.
Okay, so confidence is much better.
It's a more complicated system.
Thank you so much, Neil, for joining us on Climate Conversation. It's been a real joy to talk through all the wonderful visualizations that you've created, and I look forward to seeing even more that you're going to be producing in the near future.
Thank you.
Our thanks to Professor Ed Hawkins and Neil Kaye for their time and expertise. There's more from Climate Conversations on our YouTube channel. We have some fascinating topics coming up on the show this year, but for now, from Annex and I, thank you for watching, and we'll see you again soon.